I was going to say that in a more official explanation, but now I'm just mumbling it to Christian.
Did you write that blog post we talked about?
Ha! Oh, you were serious?
Yeah.
Okay.
It could just be me, but I do theorize
That's
that
a
the
yes.
gamer also has to be.
No. I'm working on it, though.
It is in the new document.
Yeah. This is the next step. I now have 2 outlines, so.
Once in a while, the top is.
All right, we'll just mount an iPhone up there.
The top's not really gonna help me.
It's something we don't, it's not in our culture. We want,
Yeah.
I don't know, because there's a lot of stuff going on here.
It is on.
Until it starts blinking.
Today, you know,
Oh, yeah, there it is actually.
Nerd share times, talks.
Okay.
So there's always really,
I can't see you at all.
Okay, no, don't move it. Don't move it, because I'll be over here behind
Well,
that.
you know what? It's pointed right at your desk, so the bounds are your desk.
Okay, but we still need to see the
Oh, that's already, it's on.
magics.
So the,
Magics.
Okay.
That screen is on and your picture in picture.
Interesting. Well, I'm picture in picture in the screen.
we film a lot.
Okay, so I have to go back through and move all the stuff out of the corners. No, it's fine. It's fine. We're good.
I could turn it off and on. but-
Kidding.
Okay.
We're good.
Now,
So we're live
We're live, yeah, so I'll
as far as those things go.
I'll come up and.
That's right,
Hey,
live.
Intro you.
Live in Atlanta.
Our wonderful host, Mikey, is not here this week because he's in London getting sick, as we discussed already, I guess. So I'm going to be the poor substitute stand-in. But thanks, everybody, for coming once again. And tonight, Zach is going to, I won't defer any longer while Zach takes us on to talk about Deferred. Enjoy.
All right, so y'all have all met me before. I'm Zachary Waldowski. I work here at BNR. I'm usually the one to give the introduction these days, but apparently not. So I'm here to talk about Deferred, which is something that we've created inside BNR. It's a port of a concept from another language, and we've turned it into a framework, and it's open source. You can go check it out today. We're working on a major new version for Swift 2. But let's get into it. Let's start talking about it. So, as you all know at this point is we build apps that work asynchronously a whole lot of the time. Maybe not as much as they could be, but definitely more than they used to. Definitely more than we are used to. So things like networking, when you're dealing with a web service, that has to be asynchronous. There's no way around it. You cannot block waiting for something to download from the network, even if it sometimes looks like that in the API, as Christian is mouthing. That actually has to happen on a background thread, no matter what you do. If you are streaming stuff, maybe you're doing some live streaming of something, you're doing a chat app, that has to be asynchronous. Or any sort of large amounts of processing you do. If you're doing, your Instagram for Cats app, that has to do a lot of processing of pixels and bits.
That's actually just Instagram.
Fair enough. That is just Instagram. Anyway, but a lot of the work that we have to do has to be asynchronous in one way or another. And this is complicated because threading is complicated. I hope you all appreciate this corny image representing threads because it's going to show up a lot tonight. Threads are complicated. Threading is complicated. I realize I don't have my presenter notes, so we're just going to wing this, guys. Actually, do you mind if I get my presenter notes back?
I noticed as soon as you lost your presenter notes, you went out of bounds. You're like, maybe if I get closer to the screen, I'll remember more of the notes.
Okay, so that's sort of, this is the presentation. Okay, that's better.
That's what you have in your presenter notes?
It's my wallpaper.
Cool picture.
That's right. Well, you have to appreciate the threads. Come on. That's right. Just pretend not to notice that the presentation has stopped.
don't worry, we'll edit this afterwards.
Oh, okay, we will.
Apple style.
That's right. But so there's a lot of complications to dealing with stuff in an asynchronous world. Sometimes stuff that you don't always think about. It is extremely possible, if not prevalent, for one thread writing one value on top of another, and you get half of one pointer and half of the other, and the app crashes because that's not a valid pointer. That's the concept of atomicity. You need locks around things that you share, values that you share, shared resources, shared data. And as soon as you get into locking, you get into contention because you can't just throw locks everywhere. That makes life difficult. Thread safety itself is a big issue. What what were the APIs you're using designed to work on? Were they designed in a thread-safe manner? Were they designed to work on a specific thread? And all this comes down to, ultimately, is discipline. You have to have discipline in how you write your apps, in how you assemble the different components, and how you maintain your apps, because honestly, you're going to have a lot of bugs from dealing with asynchronous code. So let's take a second. I still don't have my damn presenter notes. Where are they? There they are. They just keep going away. Okay. Gotta love it. Anyway, so let's talk about, let's take a look at how we currently do things, or how we used to do things, how we do things right now. The big one is good old delegation. It debuted with Cocoa. It was one of the major advantages of model view controller object-oriented programming. You have this, if you want to notify someone, you're doing something in the background, you want to notify someone that it is finished, really easy way is delegation. Two objects live a long time, one tells the other that it's done doing something. But that's a little heavyweight for when you're doing one-off events, because you have to set up a protocol, and maybe you have to mark some of the members optional, and you have to have a weak variable referencing that protocol. And then, if you're in Objective-C, you have to check if it responds to the selector just to make sure. And, in the early days of Objective-C, you didn't even really have protocols to ensure that the method was going to be there. You were just sending selectors out all over the place. And so this is really heavyweight and kind of error-prone, especially for one-off events. Hey, you asked me to do this thing, it's finished now. Now, we can talk about, you looking at me for something? Okay, everything's good?
Presenting?
I'm sorry. You were just kind of boring into my soul there. Anyway.
Why are you all looking at me?
I'm just talking about Christian. Christian has this look about it.
Slides from here on
It's,
out.
no.
That's the moment I've ever seen.
What am I doing here? What's going on? Sorry. All right. We're really doing fantastic. Recording CocoaHeads Atlanta for the first time, people. This was really great. Anyway, so one-off events, a little top heavy. Now, of course, because you have delegation, because you have protocols, you can do multiple events, which we'll talk about a little bit later on. But let's stick to this case for now. Now, when you're doing delegation like this, it starts to get away from you as you do more complex tasks. One thing finishes, and you need to start another. And then when that thing finishes, you need to do another thing. And this starts to get, especially as you involve synchronous events and not synchronous events, you're downloading something from a web service, that's asynchronous, but parsing it, that's synchronous. Or a mix of those things, that's where things start to get really out of hand. And, as your application grows, inevitably, it starts linking more of these pieces together. And, it's inevitable as a part of the life cycle of an app. You draw it's all I need is just one piece here, one piece there, we're good. And then, actually, this class is starting to get larger. It's sort of everywhere now. This is how you lead to massive classes. This is how you lead to just giant, ridiculous pieces of spaghetti code. This is where delegation really starts to fall down. And it gets even worse as you have these individual pieces, and as they need to get in touch with more and more parts of different things, launch different processes, you start adding more and more to these individual methods so they no longer get simple. You just keep adding stuff to them, and this is all just separate, spaghetti code. If you were having a bug in one part of the app, you start tracing back. Well, it stemmed from some crash in the analytics package. So let me go look for all the places where I told the analytics to do something. And you're like, well, it could be any of these. Well, where did this delegate get called, and all of that? It just turns into a complete mess. And what happens when you want to turn this into this? API starts falling down, because now you either have to, if you're maintaining a long-running app or framework, you have to introduce this and then deprecate the old one and call that a 1.2 just in case. Or, if you're doing it just your app, you have to go around and change every instance of this to add the parameter. Maybe I need to use the parameter. Do I need to not use the parameter? That kind of thing. And that's just the start of the problems with delegation. Like I mentioned, you have to deal with multi-threading safety. You have to deal with strong references and weak references, because when you're dealing with retain release, you have to worry about ownership. of something. But it defeats sort of the kind of model that's being introduced now, is having separate parts of your app. Delegation as it is encourages these gigantic classes that own everything, because you can't really let me section off the part of myself that deals with URL connections and make that into a different object, because if you just write it as the delegate, then it deallocates immediately because it's a weak reference. Luckily, we don't really do one-off stuff anymore. We use blocks, which we love, which are great and are awesome, and sometimes we don't like them as much. You end up dealing with sort of a similar type thing. You call a method and it has a completion. It revolutionizes the way you write code. It's more localized. It's easier to read in some cases. This looks like control flow if you're using it in Swift, especially with trailing closures. You're just doing the thing and later it comes back and executes this code. Much better. But it also suffers from some of the same problems. So let's take the classic example that I love out of Apple's code is doing network stuff. And so, you have a completion and it sends you back. Here's the information you needed. But what happens when you want to add stuff to that API? Now you have to have multiple things. But wait a second. Isn't in this case the data and the error that you get back from the operation, aren't they mutually exclusive? You'll get an error if it failed, but you won't get data, and that kind of thing. So then you have to mark them both optional. And this is what I call the Apple style of writing sort of callback completion code. This is, it turns somewhat into spaghetti, but in a more localized way. Now, of course, there's another way of doing this, which has gotten some popularity in the community, which is just let's throw blocks everywhere. Block and block and block, and success and failure. And, this is also problematic for API because, as soon as you add a third thing, it also gets out of hand, and you deal with the same problems of having to track down everywhere in your app that gets it called and add the parameter, or, maybe shift some of your code out to this thing. And even worse, completion blocks are awesome, but they don't lead well to that kind of chaining code that we talked about. The delegate stuff was downright unmaintainable, but this is just ugly. You have to deal with the pyramid of doom. As these different things, these different callbacks nest inside each other, you have to go, well, let me go fetch some JSON, and then let me parse the JSON, and then let me put the objects that resulted from that into core data, and then let me return those objects to the UI, and it just leads in this deep nesting thing of doom.
You could just make an operator.
Matt. Need a moment. All right, operators aren't the only way to do this. Let's keep going. But so this whole style, this whole model of programming that we're all very, very used to is called continuation passing. Now, this is some high-level computer science type stuff, but it's basically this idea of well, you may get called somewhere in this method. I'll provide you a method, and you'll call me with some sort of information, but I may not know what that is. So, we go back to we go back to the URL type thing, where you download something from the service. It also has to give you back the URL that you started with, because you may not know. It might have been a while. You don't know what request you started anymore. So you're continuing data. You are continuing the flow through your application through a bunch of different pieces of code. And, it's worked perfectly fine for years and years and years, but it leads to something that's unmaintainable as the scope and size of your application and the APIs you deal with grows. So let's summarize the issues with this style of programming. You have this callback delegate thing, and it's basically the same thing with a completion block, but looking at this code, can anybody tell me what thread it gets called on? Does anybody know? There's nothing explicit about this that describes where it's coming from, who it's calling on. And Apple's APIs have changed over time in how they deal with this. Sometimes they'll just throw them onto the main queue. Sometimes they'll ask you to provide a queue. Sometimes they'll just do whatever they want. And, in a similar vein, okay, so, you asked me to give you a selector for this callback. It's got this parameter I passed to it. Who creates that parameter? Is it the same URL that I gave you? Is it a URL that you've defined? Where is the data coming from? Is that from the network, or is it some representation of the thing from the network? And finally, who calls this? This may not seem like an anti-pattern in much, but a lot of things you see in iOS apps are like, I created a delegate callback for, number of sections in table view, and then you'll see littered throughout the code calling your own implementation of that delegate method. Well, because I put the information in there already. But then that leads to bugs. All three of these things create buggy code from a overall simpler looking thing. But I'm happy to tell you, the future is here. So from all these functional languages, you have your Haskell, your Erlang, your Elixir, and Lisp, which is actually where most of this stuff comes from way back in the 70s and 80s. Now, don't worry, we're not going to talk about any M words. But functional languages, functional programming, thought about a lot of this stuff already. And there are some languages out there that only work asynchronously, that everything is an asynchronous callback from another. But out of Lisp, this idea developed. We have variables, we have values, but they might not always be there immediately. The core idea of asynchronous programming is that you need to perform some calculation or perform some algorithm to get a value out. And there's this concept called futures and promises that came out of Lisp that aims to separate the value itself or the existence of a value from the creation of that value. Now, this is called a direct style of programming. In opposite to the continuation, you can access values as if they were there, but there might be some asynchrony going on. If you deal with .NET, this is async await. This is the compiler is reshuffling your code and makes it look like you're doing something imperatively, but in fact, there's a whole world of asynchronous stuff going on. Now, that's not directly the spirit of, that's not really the spirit of direct style programming, but it definitely is within the same sort of thinking, is that you're doing something asynchronous. We want to make this code look like you're doing something asynchronous, but also make it as simple as possible. So rather, the model that we're used to with continuation passing of asynchronous code is, okay, I provide you some context to the work that you're doing, a big old scary void star of work that I'm representing, information that I'm representing, and you pass that back to me later on and I can finish doing my work. Rather, direct style combines stuff like closures, anonymous functions that we're used to, with a more direct style of access. So let's take what we just looked at, splitting up the value and make value into these two separate things, future and promise. Usually these terms are interchangeable, but when combined, in use, they turn into something really interesting, which is there's two sides. You have the promise. I promised you an int. I am going to fulfill that promise. And that is the calculation. That is the creation of that value. And then over here, you have the future, which is, okay, I promised you a value. Now tell me when the value came in. So, they're normally synonyms, but they turn into something different when they're right next to each other. They're created together, and they are used together. One future is used to fill in one promise, typically, and the other way around. What's really amazing about this pattern of programming is that they are actual values in the type system. In Swift, this becomes, in other similar languages, this becomes even more powerful because you have generics. You can tell someone, hey, later on, I'm going to give you an int. And then you can bind to it in a manner that says, okay, at some point, this function is going to be called with an int passed into it. It was the int you were expecting when you called this original method. And the two great things about this is that, sort of by concept, they are inherently thread safe and memory safe. When you pass around values, let's think about Swift for a second. You have arc maintaining the retain and release count for a given item. So as long as you pass it around, it handles it. Values that you pass in and bind to futures and promises, say the promise never gets filled. That's okay, because you're not blocking some thread waiting for it. You're just like, hey, when it's done, call this block. If the block doesn't get called, it's fine. Everything deallocates and you're happy. And, in every implementation, you strive to be thread safe so that these values never conflict with each other. There's no, half-written value. In fact, in most implementations of promises, you're only supposed to write it once. You just fill it once, and then everyone else gets told about it, and you're happy. So this is not like some, icky, like mutable shared state thing where you're just like, okay, some global variable dot value equals this. No, it's a little hairier than that. And I guess a little hairier than that isn't where I wanted this to come in, but deferred. Deferred is an interesting concept. It is an implementation of futures and promises. Let's dig into this as it relates to both the concept of a deferred and the framework that we've written. So deferred comes from OCaml. That was where it was originally written in that name. OCaml is a functional language, but again, don't get scared. It's going to be all right. OCaml is also imperative, or it supports an imperative flavor. So in a lot of ways, this is exactly like Swift. Functional bent, imperative flavor. You can write that kind of code, but also take advantage of functional where you need it. Now let's go off on a little reverie. So a lot of y'all came to CocoaHeads a couple of weeks ago. Do any of you remember what an optional looks like, sort of in its type definition, in its declaration? That's right. Enum with two cases. So, the syntax sugar with the question mark expands into this, which expands into this type. So you have an optional. It is mutually exclusive. Either it is nothing or it is something. Here it is. You can think of a deferred in basically the same way. It is either, okay, not here yet, or here it is. But, again, things get complicated, or rather magical. You can't really have this in reality as much as you'd like to model it that way, because let's think about value types for a second. If you have an optional, every time you pass it around, the actual bits that make up that value are being copied around every time. So if a deferred were some kind of magical thing that had its value determined at some point, you'd have to keep a list of everywhere in memory that was, and then go back through and change it one by one. And, well, maybe the reference went away, so you have to deal with that too. And now you've invented garbage collection. That is essentially garbage collection, except you're writing things instead of destroying them. But so, a good bit of magic. But deferred is two fundamental methods. It is the fill and it is the upon. And that really cleanly makes up the promise side and the future side. You can fill a deferred with some value, and you can get notified when it gets filled. So upon fill, do this. Now upon is really powerful. It fixes one of the problems that we described earlier, which is that it has an explicit queue, and it has a functional interface. So simple, 4 characters and maybe a curly brace, and you described the access to an asynchronous value, but you're not blocking any threads. You know exactly where it gets called. If you don't provide a queue, there's a default parameter, it executes it indeterminately, quote unquote, in the background. But other than that, it checks all these boxes in a very simple interface. And what's very powerful about it is that you don't have to deal with the problems of your callbacks filling up with gunk from other parts of the app. You don't need to tell the analytics package about this one thing on this callback. No, you can call upon as many times as you want. Fill only once, upon as many times as you want. So in this way, what we just talked about, deferred is a combination of a future and a promise. So you have those things represented in one type in Swift. And this can be really amazingly convenient when you're dealing with your own APIs. Say you have a store class and it talks to a web service and ingests it, but it can also vend that back out to someone else and say, here, you can also wait for when it's done. But this model is not always safe because anybody can fill it. This combination, these two things are great within your own APIs. So if you can use a deferred within, say, one class, one view controller, use as many deferreds as it wants within itself. But as soon as you cross API boundaries, you have to deal with more complicated things. So we have two major types in deferred and the future, which is basically just taking deferred and removing the promise bit from it. And you can accomplish that by basically, cutting out the parts of deferred, putting them in a box, and say, here's a box. It's a future now. I don't have an int yet, but you will have it one day. Here it is, and you can't write to it. You can only read from it. A future basically has one method on it, which is just the upon. There is some other conveniences too, which we'll talk about in a minute. But it is fundamentally, I have a value here, and you can wait for it later. Again, the advantages of this are many, because you can pass around this type in the type system. You can store it to a variable. You can put it in a dictionary. You can put it in an array. I don't recommend either of those when you're dealing with multi-threaded scenarios, but it's possible with sufficient locking. But you can combine these things and you can distribute them out. You can copy them. You can return them from APIs, so you don't have to deal with the pyramid of doom, because you can compose deferreds really well, which we'll talk more about in just a moment. You can return one deferred and then turn it into another. Create a new deferred that changes the value that it gets out of another deferred and does it, which is sort of a map, which we'll talk about. So more bits, like I just said, you can transform deferreds. It comes with a whole host of methods, combining multiple deferreds that are in an array, or you can combine two of them together, or you can map them. So one really just amazing important example is you download something from a web service, then you map it, you parse it, you turn the data into JSON, and you turn the JSON into model objects that your app understands. And you can do this using simple operators on deferred. And this is it. This is doing a complex operation, but as you section off the responsibilities of your app, as you make the individual types and classes that you write have less in them, less responsibility in them, deferred allows you to rejoin together asynchronous operations, but ones that only involve their specific authority. So, the web service class is going to be in charge of shuttling things from data to JSON, and it can do that asynchronously however it wants. Christian?
Is that returning a deferred of an array of posts?
That's right. So maybe the S shouldn't be there. But yes, this is downloading just one bit.
We're mapping, right? So
yes.
We have a lot of JSON.
Yes, that's right. So no, so not in this case. Not in this case. So map doesn't work like map on array. It works more like map on, say, result, which is still fundamentally the same thing. Is that there's a value in here.
Like map on optional?
Yes, map on an optional. That'd be that's a better one. So it takes the value that's in here, and whenever it's ready, pass it to this function, and then fill another deferred with whatever the result of this function is. Any questions on that, or any of these? All right. So this is extremely valuable in a lot of ways, because you can pass anything into a deferred, and an int, an object, anything you want. Now we talked a little while ago about having many different events that you respond to using delegation, or a success or a failure, separate callbacks for blocks. And where this gets, where deferred helps you handle this is any enum can work in this too. A deferred can handle or contain anything. It can contain a tuple, a list of things, an array of things, any object, any class, because generics are powerful. And so you can have an enum that represents multiple separate cases, of an event. Hey, I asked the web service endpoint and it gave me back, a list of posts. I went to the web service endpoint and it gave me back just one post. I went to the web service endpoint and it gave me back garbage, actually. Yeah, Matt.
Is there the pattern of using deferred, or are you gonna have more chance of having like nested deferred?
What do you mean when you say nesting?
Yeah, I'm sorry. Where the placeholder type there is a deferred of deferred something.
Right. So you don't typically have deferreds inside of deferreds. Instead, you map them, which you would think like with arrays you would end up with nested arrays that way. But
when I see flat map, I see.
That's right. So let's go back a bit. So a map allows you to take in the value from that deferred and turn it into another value, and then out of that you get the deferred of the new value. Right? Is everyone on board with that? So flat map gets gets away from that a little, because you can that allows you to take in the value from the deferred when it comes in, then return an entirely new deferred for it. So this is busts whatever Matt calls nesting. There are a lot of different terms for nesting.
It sounded like you said the same thing for map and flat map.
No, so
map takes in a deferred.
sorry, yes. So the inner function, the function that you give to flat map itself returns a deferred.
Okay.
And the flat map function itself returns that deferred, returns a deferred of the same type. So how this works is you can this is also useful for the downloading from a web service case, because say you had two web service endpoints that one required the results of another. So I need to download the list of user IDs, and then I need to request profiles for all of those IDs. FlatMap allows you to start a new asynchronous operation with the result of the old asynchronous operation and then combine them together down the road. Does that make sense?
So, let me try and say this a different way and see if I've got it right. Both of them will take a deferred and give you back a deferred, but FlatMap, the transform operation, the function that you're passing in, it itself is promising already to take a deferred. In other words, it's already going to wrap into a deferred. So FlatMap will unwrap it and rewrap it back into the deferred, whereas map is going to take a function that doesn't have anything to do with deferreds, and it will run it through that.
That's right. So map is helpful coming, like you say, coming from the world of no deferreds. It's just one value to another. But as your application gets bigger, you can compose different pieces of FlatMap, different flat maps using deferred. And so you can have, one result chained to another in a very succinct way.
In other words, you're forced into either map or flat map based on the type signatures you're working with.
Yeah. I wouldn't say forced. This is the flexibility it provides. Yeah, you have the privilege. That's right. That's right. And then and works similarly. It's easy to brush over. It just combines the results of two separate deferred. So if you have an int and a float, you get a deferred of int comma float. A tuple of the two. Same kind of thing. But so let's roll back around. So you can put anything you want to in a deferred, especially about
Sorry, before we move on, so I'm going back to Matt's question. So if I call map on and passed in the closure that referred to deferred, returned to deferred, I could get a deferred inside of deferred.
Yes, and you
What
poor
I should
soul.
be doing is calling flat map in that case.
Yes.
Flat map flattens back out my multiple deferreds into one.
That's right.
Sort of.
Yeah, sort of. Anyway, so any more? You know what? Let me keep asking. Any more questions about the different kind of transformations you can do? Because this is really the selling point. This is how you avoid nesting. This is how you compose different operations out of many parts of your app.
Are we going to see more sample code?
I'm sorry?
Are we going to see more sample code? I mean, I think I generally get the idea.
No, but we can write some more sample code,
Okay.
like right here, like on this computer.
I mean, you can do it on my computer, but it's not going to be as useful.
No, I just mean like not later. Like we're not deferring the Okay. All right. But yes, I promise that. This next point is going to fall over like a lead balloon because I felt like we've built up so much towards it now. But anyway, like a really common pattern is going to be representing either the success or failure of some operation. In fact, in our experience, it's been the majority of times that we'd have, a thin delegate. You either got this thing, hey, it's done now, here's a thing, or it failed and here's why. And out of that, it's really easy to have a deferred that has a result inside of it. If you have your favorite result type or you've built your own because it's seriously in with two cases, you can do that because, again, you can put anything inside of a deferred. Any questions about how this works? It's very simple. You can put a result inside of a deferred just like you can anything else. Now, I said we wouldn't have sample code, but let's think about the effects of this. So we've been talking a bunch about like a web service. How does your app handle changes over time? We mentioned some of the internal abstractions of things. and how nesting completion blocks falls down. And the question of why we like deferred is what happens when these things change? When these pieces stop fitting together, how does your app cope with it, and how do you not break the build horribly? With deferred, this is actually really easy a lot of the time because you compose the ways you use different bits of deferred. So say a web service is going to return a deferred that has data in it. And then some different layer of your application will be the one that translates that data into a JSON blob, and another part will translate the JSON blob into some model objects, et cetera, et cetera. And so let's say, the client comes back and halfway through the project, we're not going to use JSON anymore. That's rare these days, but it happens. Or, we're going to change this about it. We're going to change the headers you have to post. And that changes the underlying API you'd have to use. But deferred, because it exists in the type system, you don't have to do things like go around and change signatures. These things compose with each other. So you just have to go to the deepest level in the stack and ideally change it, once. And the rest of the app copes with the changes. Okay. Any questions about that example?
I feel like it's kind of like a question and a comment. You've been emphasizing it's very swifty of you. You're emphasizing the value of deferred being a type and the generic placeholder giving the compiler good information for when the type is used.
Mm-hmm.
So it helps us to write, hopefully, safer runtime code.
Yeah.
But it seems to me that, and maybe you're getting to this in the future segment, it seems to me that one of the big selling points of deferred is maybe that dream of writing stateless code.
Right.
Like eschewing state through asynchrony.
Okay.
And the further, the other functional concept of avoiding mutability as another vein of writing very stateful code.
Oh yeah, absolutely.
And I'm wondering if you feel like, how would you characterize that comment vis-a-vis the point that you are emphasizing?
Yeah, so in fact, that's a great point to bring up, is that Deferred presents a very simplified API to do these things. It is, it edges into, it sticks a toe into the world of functional programming and functional reactive programming, and it helps you get towards those things like focusing on asynchrony and, working with stateless information. But you don't have to go whole hog into it. Deferred is something that scales with your application. Deferred is something that fits in as much as you want to use it or not. You'll find yourself saying, if you use it, you can choose to or not to. You didn't sign anything with the pizza to require you use deferred. But it is a simple paradigm that scales up as your application gets bigger, as its needs change. It helps moving towards that world without having to adopt a whole lifestyle, about it. You don't have to learn really anything more than this one type. Now, you can go down a lot of different roads and paths. In fact, what works great with the deferred result is something that combines the two, or really just flattens them out into one single type. But you don't have to. We have people building an app right now that uses deferred just like this all the time and doesn't need to do anything more with it, because we are able to teach the API of deferred to someone else who is completely uninvolved with BNR and probably lives in a different country with much cheaper labor laws. But we are able to teach it to them in 5 minutes. Anyone can roll up on a project. Mike, you can maybe speak to this. You can roll onto a project and sort of get adjusted to the flavor of deferred really quickly, because it looks a lot like what you're used to dealing with. It just has a different flavor to it. It is that again, the direct style versus the continuation style, because you're used to the continuation style from Cocoa, and it's a little mind-bending to work with it, because you hear these things, you read the blog post and you're like, oh, you should be avoiding state, oh, you should be doing everything asynchronously, but how do I do that without making my code look so ugly? And it is through a mechanism like deferred that flattens these things out, that simplifies them, pulls them back into something that looks asynchronous, like you're opening a new scope, it's doing this later on. You know that just by seeing the 4 characters upon. You know that, but you don't have to. You don't have to deal with nesting or completion handlers. You're ideally just working over simple amounts of data. So yeah. All right. So let's. So yeah, this goes over most of what we just said. But deferred is convenient, is simple to use for all those simple cases. And then it grows with you as you need to do more advanced things. As you use deferred in different ways, you can adapt to those different models that it provides. You will start to recognize, bits of boilerplate that you've been writing all along. Like, well, wait a second, why am I writing the same code to switch over whether there's data and an error, or maybe a data or an error? Why am I writing that every time? Why don't I pull that boilerplate out? And it's adaptable to many paradigms. Deferred fits in with a lot of different ways you work, and it works with a functional bent. It works with an imperative bent. It works if you're a reactive Cocoa user or if you've never left Cocoa. And we feel like it's a very Swifty thing. We've tried very hard to sort of adapt along with Swift as Swift has changed, and we hope to keep doing that at least until they put it in the standard lib. And so. That's all I have really for now. Deferred is open source today. Our master is a little bit of an old version. We're working on a big 2.0 release coming up soon. Our documentation is publicized here.
Is it on GitHub or GitHub?
No.
GitHub. No, yes. No,
It's the new thing we're trying out here.
that's actually GitHub. We'll Photoshop that in over the video. And apparently get me a typing teacher. And so you can file any issues or comments on our GitHub repo, or email me directly, zachary@bignerdrant.com. Any questions?
Well, I'm
Christian.
gonna go on can we go and see some sample code and just implement it on both sides? So as the consumer of the deferred and the filler of the deferred.
The consumer of the deferred and the filler of the
punner
deferred.
of the deferred. And
The punner?
Yeah, funner.
That's the word we're going to use now?
deferred and,
Okay,
So we
yeah.
have a Zelda and a funner?
Yeah, so here. So I have a playground. It is not on that screen, is it? No, it's not. So I have a playground. Nope.
You may want to turn off.
just
Yeah, let's turn off mirroring.
a shortcut for that, right?
Yeah, just click.
Well, there's also the command F1.
Okay. So you have a playground up. Hopefully it's imported deferred correctly.
I guess we'll know shortly.
Here, let's go ahead and.
Feature.
Oh, whoops.
We have to import that. Yeah, there we go.
So let's go ahead and turn off. Oh, it changed, didn't it?
Well, there's the play button down at the bottom. Is that what you're looking for?
No, I'm trying to. There we go. All right, because we're doing stuff asynchronously, and it's going to freeze. There we go. All right, so let's try this way. So we want to build the producer side of a deferred, right? Okay.
Just do something simple like an int or something.
Yeah. Live coding, it's the best, isn't it? All right, so we're going to do this. We're going to create a deferred. I'm surprised it's not going red on me. Hey, it's all working. Okay, and we'll go ahead and return that. Now let's do this. So let's dispatch after. Oh golly, let's not do that.
Let's do sleep. Can you use sleep in Swift?
Yes. So let's dispatch async and do sleep. That's a good idea, Christian. Thank you. So let's get a global queue and put a block on it.
I feel like you should put a block up.
And so, after some amount of time, so, we're obviously crunching a lot of difficult data to get this int. And, it's very simple. So you fill it. And so down here, let's request int. And then upon in queue, because we have a convenience method for that, you print out the value that you got. So,
And you could use normal closure type stuff with val, colon, you know.
oh yes, that's right.
Yeah, it's just normal closure stuff.
And let's decrease that to 1 second, or else we'll be waiting here for hours. All right, so it's very simple. So, you kill it, you run it, it gets the thing, and then it pops in a second later. It's a very simplified model. This is it. This is all it takes. This is the producer side and the consumer side. Hopefully, you will not use sleep. Hopefully, you won't use sleep. What's the next step we can take it? Christian,
Stick the,
Map it,
map it. Okay.
so we could,
well, you can stick the value returned from request in a variable.
I'm sorry.
Request in is returning a deferred, so you can stick that in a variable and then
Yes.
do it with it.
So let's do that. Let's comment this out for now. So we'll go D. You said map? Let's do map. Map with, yeah, so string. Oh, this is so dangerous. There. Let's do it just super awful. That's not going to work either, is it?
turn it.
Oh, because it's just printing it out. Right. So, yeah.
Oh, okay.
And then you can now this deferred that results out of the map.
Oh, yeah, it's just that's it,
And so after a second, it'll fill in the int deferred, and that goes into that method, creates a string from it, fills a deferred with that, and that's what you're getting through the upon main queue.
So d.map, returning a string from that, so we're getting instead of doing that in one step, yeah. And then delete the
Whoops.
upon main queue part. So that gives, so deferred 2 is gonna be a deferred of string.
That's right. Wow, that's really tiny.
Can it hold under control in 2 fingers?
You have to set.
You have to turn that on because I have good eyes, so I don't typically.
Zigger, someday it'll be old.
Someday I will be old, and you will all be laughing at me.
Yes.
Anyway, so yeah, it's a deferred string. So the first one was a deferred int, and we map it, and it becomes a deferred string. I should zoom out now.
Now, there's some way you could use this to flat map.
Yes. So here.
Yeah.
So let's request string with an integer, and that returns a deferred string.
Yes.
I wonder what this method is going to look like, folks. It's really
Hey, sometimes these very simple, like once you start throwing all the other crazy JSON stuff in there,
all right. So you have this request string method. It looks a lot like the request int method, but it takes this extra value in. It takes some information to go with it. I need this to be able to make this very expensive calculation, which involves here. Let's make it 2 seconds because it's really expensive to turn an integer into a string. And so yeah, so like we said, so let's comment this out and move it down. So you have now a second you want to kick off this next asynchronous operation, and you can use flat map to do that with a request string. Is it not like that?
don't get all fancy here.
Why not?
Oh, it's just, yeah, it's just, yeah.
Just pass the function in, and that one eventually gets filled in as well.
And that's a deferred of a deferred.
No, yes, it would be a deferred of a deferred if you used map, but because you used flat map,
Ooh, go ahead and use map.
stab.
Well, can you show me what's in the results sidebar? Uncomment that again.
Yeah.
It looks like a deferred. Oh no, sorry, never mind.
That's
Module name.
Framework.
Yeah. But so yeah, let's take it to map. And you've just confused everything. So you print it out, and you got oh god. You just get some deferred stuff down here.
Deferred.
And so you notice, like, yeah, it's coming in. It's the deferred string. So I'd have to,
Upon that.
I'd have to upon that to get the value out of it because you don't know that it's there yet. That's the only API that we provide.
So upon is always a closure.
Yeah, that's right. Upon is always a closure. There's no way to ask it, hey, do you already have the value? Because we don't want you to ever trick yourself into thinking that you're doing something synchronous. We don't ever want you to accidentally block and wait for something. The only API is an asynchronous one, give or take.
Yeah, I can click on line 36, the deferred.
This one, the deferred 2?
No, I'm sorry, the parameter.
Oh, yeah, it's just deferred string. Because we used map instead of flat map.
I love all those deferreds over there.
You're just making me sad, Steph.
I know. Should be printing.
And then you could just and deferred 1 and 2 to make,
That's right. Deferred 1 and deferred 2 upon main queue, and now you have
that's nice.
I'll just not do anything with that for a second. But yeah, so you can use and to combine them together.
Now, and took in future type? Is that what it said?
Yes. Which is a kind of thing that deferred is. It is that future.
Yeah,
What
if
is
we
future
move
type
it-
a protocol
Yes.
that deferred conforms to?
Yes.
When you used this in your last project, did you use the int and the string and the like, or did you use $0, $1,
Oh, that's a good question. It really depends on the context in which it is used. I think 2 is just about the limit where you need to stop using $0 and $1. But I generally lean towards giving variables in, unless you can't usefully name them. If it's just going to look like deferred, then maybe try and omit the parameters names.
Did you ever and more than 2 or 3 deferreds?
I didn't, but I've heard mysteries of
Seems
no.
like you might want to.
So I would just give you a tuple of 3 things?
Yeah, a couple of 3 things, a couple of 4 things. The problem with that is you can't take that number too high because Swift starts to really hate you. And by that I mean type inference really starts to get upset with you. So.
What were you thinking about? Very
Well,
hard. It's kind
it
of-
just seems like if you and so many different deferreds together that if you're starting to look at like a different model for passing your data.
Yeah. At that point, you might want to use flat map to turn it into one type. You might want to. My big suggestion usually is to if you're pulling together 3 or 4 different asynchronous things in one thing, you should start looking into sort of abstracting that away. Like maybe you can do 2 of the ands down in one level deeper in your application. Like it just seems like too much is going on in one place. Zorn.
Do you have any commentary on how this compares to things like Promise Kit and others in the community?
Yeah, so let's see. There's Promise Kit, there's Bright Futures, the Bolts from Facebook. I have looked at them because I can rattle them off. You see, I'm very special. No, all I know is the names.
Therefore, I have looked at very impressed.
That's right. I know the names, so therefore I'm very special. I like the others. So the difference that we are trying to champion with Deferred is that this is a simplified model. All those frameworks that I just mentioned are all really good, and they do a lot. And there are a lot of phrases, there are a lot of $5 words that are hard to learn. And I'm not trying to be anti-intellectual by saying that. I just mean it's very hard to look at someone else's code written in that and not have to learn the framework already. I know from firsthand that sometimes that's the experience with Deferred, and that is our effort as BNR. That is sort of our our bread and butter is making things easy to learn. And so what Deferred provides is like you have like 10 methods to learn, period. And most of the other future kits, future and promise kits, have several classes, several methods to learn, several protocols that all interact with each other in this way. And really what we're trying with Deferred is to boil it down to the upon, the fill, the map, and the flat map. And the rest you can learn. The rest we want to provide, and we try to provide. Some of that hasn't taken shape yet inside BNR, but we're definitely trying to get there without upping the complexity. Yeah.
I have another question, but anyways.
No, go ahead.
So I obviously have a little bit of experience working with this, and you mentioned the result type as there. What are your current thoughts on the new error patterns being introduced, and how will this evolve to kind of work with them?
Yeah. So throwing, we're big fans of throwing here inside of BNR. Well, some of us are. I don't know about you, Mike.
I don't know yet.
Some of us like it, but the big falling point is that it's only really for synchronous code. It's only for imperative code, and it's not really tuned for asynchronous functions yet. So it doesn't really matter whether I like it or not for this use case because they haven't provided something for it. We anticipate that there's going to be something for that down in the future, but we have no way of knowing. In an ideal world, it looks something kind of like you have in .NET, with async await. But until then, Deferred exists, and it exists really well. And Deferred is going to keep working for years and years and years to come, because we've whittled it down to the bare minimum that's necessary. It's going to keep working because it just works over simple types. So even if they do never provide an answer for really great asynchronous error patterns, Deferred is still going to be there for you.
I think the other bummer that result has over throws,
Yeah.
in my opinion, is that I can type the result,
Yeah,
but I can't type the throws.
yeah.
I
So you don't like that you can't type the
I
throws.
don't like that.
Yeah. I don't know.
It feels like I have to write this stupid switch statement where I'm like, catch these 3 errors that I can conceive of, and then here's this catch-all thing, and I'm just gonna print out the error.
Yeah, but I mean, I feel like there should be some facility to provide an annotation, but I also don't think it can.
That's exactly, one of my biggest problems with Java is that.
Yeah.
Exception handling. It's a nightmare. I hate it. I've always hated it.
Mm-hmm.
Some people love it. I don't like using it because you end up using it for control flow.
Yeah.
And Swift's really isn't there for control flow. It's for recovering from misinformation.
Recoverable errors.
Yeah, recoverable errors.
That's-
And so, yeah, I agree that it isn't perfect. I think there should be type annotations for it, but it's an improvement because really, like from what we did last year with Swift 1 is that we just really didn't handle errors that well. And that's not great. Even if we, when we started adopting result widely, we didn't handle errors that well either because it's just like, oh, well, I turned this result into that result, into that result, into that result, and we're done, right?
I just resulted it away.
Yeah, it's just, and then at the end, and then when it got to the UI, we used .value, and that was an optional. So we just threw away all that extra.
I can't tell you how much Java code I've seen that catches an exception and throws it again. Catches it and throws it.
That's
What's
pretty
the point?
awful. That is pretty awful.
And it's all over the place. You see it everywhere.
Well, and so that's a shortcoming of Swift.
But you can't do anything about it.
Yeah, that's a shortcoming of Swift right now, and it's going to be a big problem if we do get sort of annotated errors. Is that what happens when those change? Somewhere deep in your API, if you add a new error to your error set, and your application was relying on bubbling up the errors to somewhere, the compiler is going to have to be really smart in order to type check the errors all the way down throughout your application. I think it'll be fine.
I think they would make a huge effort on that, I believe.
I bet they would, but it's still complex, and it's not just
Better
the.
to compile time error on that.
That's true. It's very true because but what happens as
Start propagating up, they get out of control.
yeah.
And that's the one big difference between the Swift's error handling.
Right.
Is it's not propagating all the way up to where you're It just gets to be a nightmare when that happens.
And what Swift has to worry, what Swift is going to have to worry about that it doesn't right now is ABI stability and frameworks. Building out libraries. What happens when a framework 3 levels deep in your application that you don't even know exists? Like a framework that you uses a framework that uses deferred, and deferred throws up some error, or deferred has a typed error, but then in version 1.2.2, it adds a new kind of error to the list.
And now that you're talking about it that way, it might seem sort of impossible to graph that.
Yeah, it's going to be hard. Yeah.
So I have one last question.
Yeah.
I'm sorry to keep talking so much. Is a mutable deferred sort of like an oxymoron?
Yes. There's really no such thing. Deferred is a value type because it doesn't need to act like a reference type. We don't need equality. We don't need pointer semantics. This is a bag of value that comes in later on. It is a value type that acts like a reference type for a couple of reasons. One, the one that I just mentioned, and the other being so that we can introduce optimizations later on, like Swift has. So yeah, there's no such thing as a mutable deferred in the sense of it's just a value that you get notified upon later on.
And the moment you introduce mutability, you introduce red.
That's right. Anything that becomes mutable becomes very strange and wibbly, so we try to avoid that, at least until we get deep down into the implementation of deferred. Christian.
Does a filler do really anything besides fill? Like I know there's fill if unfulfilled.
Not anymore.
Oh really?
Yeah, we got rid of it.
No,
You weren't there for that fight.
Oh man.
It went on for
I was.
yeah,
it went on for hours. It went on for
it
hours.
was literally out.
Well, I won't ask for a recap on this.
No, please
The
God.
right decision was made.
I was
Yeah.
about to go to the same place, but right here we're
Thank
using
you.
deferred everywhere, which means that anywhere along there we could start filling them in.
Yeah.
But really, we should be using promise and future
Yes.
types instead.
Yes.
Could we do that?
Maybe. I haven't. No, not really, because like in this use case, it's perfectly reasonable. Or like how we're doing it here. Like if you're using it inside a type or inside something, deferred is going to be 100% a-okay, and that's why
Well, we
like
could have class 1 and class 2.
yes. So as you start getting across API boundaries, you should start wrapping the deferred. And I'm not going to do that right now because we'll be here for hours.
Fair enough.
But that's all documented. So if anyone has anything to say about it, ask me questions. Speaking of, any more questions?
We need a slide for that for sure.
There was another reason, Christian. Anyway, any other questions, folks? All right, cool. I was asked to throw out one last thing as we are here, especially because it is now on video. You all come to Big Nerd Ranch for CocoaHeads Atlanta, and we love having you here. But, Big Nerd Ranch does other things than host pizza for you. We develop software, we write books, we teach stuff, and if any of you all are interested, we are holding a class in designing for iOS using Sketch, January 25th through 29th at gorgeous Callaway Gardens here in Atlanta. Visit our website for more information about that if you're interested, and that's the end of my pitch.
I have a pitch.
Christian.
I have a pitch. Matt
Christian.
just walked out, but his Swift book is coming out in December, and my iOS book is coming out in December. So woo!
So that's so. Let me repeat that so it gets on camera. Is that Swift Programming: The Big Nerd Ranch Guide? Our first edition is coming out next month. We're very proud of that. It's a fantastic book. I know, having taught it. It's great. We love it. And the fifth edition of iOS Programming: The Big Nerd Ranch Guide, starring Christian Kerr, who is here tonight, is also coming out at around the same time, right? So, at the holidays. So you can pre-order on Amazon now. And this is when someone would edit it to put in a link like right here. But that's not happening.
That's not happening, I'm just telling you.
So anyway, thank you all for coming out. This has been awesome.
Nice little.
Just
This doesn't need editing.
point down.
That's just this.
Subscribe now. Subscribe now.
That's oh no. That's press the button over here, please.
That dictates your page layout.
Yeah, right.
So you're saying that I need to like.
You have to sit below.
That's just
I'm gonna cut all of this.
Yeah.
okay. All right. Anyway, so that's it for me. Thank you all for coming out. Have a great night.
Does anybody use Sketch or work with people that use Sketch, out of curiosity?
We do.
Well, thanks.
There, I think there's an audience plant.
Yeah, right.
Before I came here, yes, we did that.
Oh, okay. Cool.
It's a kick ass.
It's gaining very, very rapidly in mobile.
Yes.
If it just stopped being so darn buggy, I'd be much happier with it.
I mean, software sucks.
Software sucks and scroll views suck extra.
All right, I'm gonna go hit that sound.
All right, thank you.
I'm trying to get better. I'm actually, I'm pretty sure.
Did we record the last one, by the way?
No, we haven't recorded any of them.
Yeah, because I wanted to become better with it. Just for perfect like